Okay, so finding the volume, area of the base, lateral area, total surface area. The first step is probably going to be area of the base. The base of this is this shape right here. Because that is the shape, as we've mentioned before, that we could grab and pull through the whole shape. So that's our base. So we're going to have to cut this into shapes that we can find. Well, we'll cut the half circle, obviously we have to cut off, and then we'll cut off that triangle there. So there's 1, 2, and 3 sections. Section 1, how do I find its area? Pi times radius squared divided by 2. Right? So that's about 100.48. Look good? Okay, shape 2 there is 20 by 16. Otherwise known as 320 square inches. How about shape 3 here? This is 16, what's this? 30. Perfect. So that's 16 by 30 divided by 2. So 240 square inches. So that makes the area of my base 660.48. You guys concur? They're confused, Eugene.
Where do you get 16 now?
8, so it's 8 there and 8 that way, so that's 16 total. My volume then is just the area of that base, 660.48 square inches, times my distance between bases of 40 inches. What is that? 26. What's that? 496.2. Yeah, I was say 26,419.2. There we go. That looks better to me. So around 26,4 to 26,425. Next, lateral area requires that we know what? Yes, for the lateral surface area, LA or LSA, depending on how you want to abbreviate it, we need to know the perimeter of the base. To do that, well, we have 20 plus 50, right? The 20 obviously came from right here. Where'd the 50 come from? Right here. That says 58. Yeah, but this last 8 is the radius of the circle. So it's 50 is the straight part from here to here. So we still need this slanted piece here, which is going to be the square root of 16 squared plus 30 squared. Right? I'm just rewriting it as a squared plus b squared equals c squared, but I'm just going to do the square root right there. That should come out to be 34. So that's 34. So I'm going to add 34 down here. Then I still need to add the arc of this circle, half circle. So that's going to be pi times 16 divided by 2, which is about 25.12 inches. Correct? So that all adds up. What is that? 129.12 inches is the perimeter of my base. So now how do I use that to find lateral area? My lateral surface area? That's the perimeter of my base times the distance between bases. (5164.8) inches squared. That's my lateral surface area. So then, the total surface area is the area of my base, 660.48, plus the area of my other base, which is 660.48, plus 5164.8, which is 6485.76. Like that. Inches squared. What do you think? Better than a sharp stick in the eye? How many of you came up with that for total surface area? Is anybody not sure how I got it? You're not sure? Okay. Do you understand how I got the area of the base? Okay. Do you understand how I got the perimeter of the base? The perimeter? Okay. So you got the 20 here. That one was given. That one's the easy one. The 50 down here is a little trickier. You gotta see that last 8 is the radius. So subtract that from 58. This is 50. Okay. Then it's the last two pieces that are difficult ones. You have the triangle here to give us this one. We already knew that was 16 and that this was 30. So that's a squared plus b squared equals c squared gives us the 34. And then this piece here is the half circle. Has a diameter of 16. So pi times diameter would give you the whole circle circumference. So you had to divide by 2. Gives you the 25.12. So we add those three up. We had the 20 on top, the 50 on bottom, the 34 is from the slant, and the 25.12 is from the half circle. You get the perimeter. And then the lateral surface area, which is all the area except for the two bases. So that's this here, and then the bottom. All of it except for these two bases is the perimeter of that base times the distance between bases, or the 40. So we just took the perimeter of the base times 40 to get that lateral surface area. So we have a base on each end, so we have to add 2 of those plus the lateral area. So 2 bases plus the lateral area. Now, I'm going to let you off the hook. I would not ask a question like that on a test or quiz unless it was an extra credit question. I do have to come up with a very colorful extra credit question for you guys. Just for fun. Well, my fun. It entertains me. That's what matters. You guys should know by now. That's what matters, as long as I'm happy.
Amuse you or just crazy or what?
Well, it's not near as cynical as it sounds. I actually do enjoy watching you guys work at it and having some people see it, oh, and when they see how to do it, because none of these are incredibly difficult to do. The difficulty is seeing how.
Yeah, remember all the steps.
Once you see how to divide it up so you can find the area, and once you see remember the difference between volume and lateral area, because they both are multiplying by that distance. But volume is multiplying the area of the base times the distance, and lateral area is the perimeter of the base times the distance. Then which ones do I add up to get which thing? And I mean, they said doing it's not that hard. It's the mechanics of it. It's all rectangles, triangles, and circles. But you got to see how to break it down and remember which process is it that you have to do. But it's not simple by any means. The hard part is knowing what to do. Doing it is the easy part. That's why I have students tell me all the time, it seemed so easy in class, and I got home and had no clue how to do it. That's because in class, I'm kind of leading you to, I'm giving you hints as to what you do next. Doing it is the easy part. It's figuring out what do I need to do is the tough part.
It's an time.
Yeah. Kind of the opposite of working in the shop for you guys. Knowing what to do is the easy part. Making the machine do it is sometimes the tough part. So today we're going to look at something just a touch different. Let's take a look at a 10-inch square base . 12-inch tall pyramid. Pyramid. Now we've defined volume to be the area of a base times a height or a distance between bases. Well, this only has one base. But if you recall, when we did areas for triangles, well, we did define the area of that triangle, and it didn't matter what type of triangle it was. To find the area of that triangle, we found the area of a corresponding rectangle, and we divided it by 2, right? So we had to relate the triangle to a rectangle. So it makes sense that we're going to have to relate this pyramid to a corresponding box of some sort. But if I took a box if I cut it in half, do I get a pyramid? No. If I cut this box in half, what I get is a wedge, not a pyramid yet. If I take that pyramid and I cut it, or that wedge, I should say, and cut it, now I get a pyramid. So I have to cut the box in half, and then I have to cut it's not another half because the bottom's wider. I have to cut another little piece off of that wedge to turn it into a pyramid. So it's less than half, but more than a fourth. And what it comes out to be is 1/3, or divided by 3. So the volume of a pyramid is the volume of the box divided by 3. In other words, it's the area of the base times the height divided by 3. The way I remember it is like this. How many dimensions is a rectangle? 2 dimensions. Triangles, 2 dimensions. When I do the area of a triangle, it's the area of a rectangle divided by 2 because it's 2-dimensional. How many dimensions is a pyramid or a box? 3 dimensions. So when I do the area of a pyramid, it's the area of a box divided by 3 because it's 3-dimensional. Make sense? So down here, to find its volume, I'm going to find the area of the base. What's the area of the base? Yeah, 10 inches by 10 inches, or 100 square inches. So then the volume of the pyramid is going to be the area of that base times the 12-inch height divided by 3, give me 400 cubic inches. That's not so bad, right? Just like finding any of our other volumes, you just got to remember to divide by 3. For surface area, there's 2 big differences. First of all, there's only one base, just the bottom, the 100 square inches. And the lateral area is no longer rectangles anymore, are they? They're triangles. Triangles mean we're going to divide something by 2. But then the other difference is, in the lateral area, the surfaces don't go straight up and down anymore. In our box, in this box, the height of the box was also the height of the lateral area. Here, the height of the pyramid is not the height of the lateral area. The lateral area goes at an angle. We need to know that distance. That is called the slant, or the slant height. It is going to be slightly more than the height, because the height goes straight up and down, and this goes at an angle. How do we find it? Well, you got it. We can make a right triangle like this. This is the right angle. This right angle is with this surface, not with the base of the pyramid. This is 12, so the 12 inches of height. What's this piece down here? 5, half of our 10. So this is going to be the square root of 12 squared plus 5 squared, giving us 13 inches. So the first big difference is we have to find, for lateral area, we have to find S, which is the slant height. And we do that by doing Pythagorean theorem. It's the square root of 12 squared plus 5 squared. Gives us the 13. We still need the perimeter of the base. But it's generally going to be easy. Why did I just do 10 times 4? Maybe because I'm too lazy to write out 10 plus 10 plus 10 plus 10, right? It's 4 tens around the base. 40 inches is the perimeter of our base. So then our slant height, and our lateral area, I should say. Lateral area is not the height anymore. It's the perimeter of the base times the slant now instead of the height, and then divided by 2 because they form triangles. So the perimeter of the base is 40 inches times the slant is 13 inches divided by 2, giving us 260 square inches. You with me so far? So now my surface area, I only have one base, which is the 100 square inches, plus my lateral area, which is the 260 square inches, giving me a total surface area of 360 square inches.
So if it's an irregular pyramid,
We're not going to deal with the irregular pyramids right now, because they're a real pain. That might would appear as an extra credit question. An irregular pyramid, you'd have to break down each face, because each face will have a different slant height, so you got to do triangle by triangle. And that's only assuming, even in an irregular pyramid, you're assuming that the peak is at the center of the base. If it's not at the center of the base, then we got to do some really weird stuff. We don't want to do weird stuff. I'm guessing you can guess what's coming next. A cone. This is basically a pyramid. So to find our volume is the volume of the related cylinder divided by 3. Yep. So we got to find the area of the base, which is pi times 8 squared. Where did the 8 come from? Half the 16. Very good. That is going to be 200.96. Screw it. Let's make it easy on ourselves. 201. So the volume is going to be the 201 inches squared times the 15 inches of height divided by 3. 1,005 cubic inches. Make sense? So now for our surface area, no problem. For surface area, we need to find the perimeter of our base, which is just going to be pi times 16, which will be 50.24 inches. What else do we need to find? We need to find the slant. which will be the square root of 15 squared plus 8 squared. Does everybody see where the 15 and the 8 come from? 15 is just our height. The 8 is half of the base. That forms that right triangle. That's going to give us 17. So S is 17. So now the lateral area, 50.24 times 17 divided by 2, which is going to give us 427.04 square inches. Look good? So now that's lateral area. Total surface area will be the base, the 201 square inches, plus the 427 for the lateral area, giving us 628.04 square inches. What do you think? Still better than a sharp stick in the eye? That's that triangle there. So we've got a squared plus b squared. So 15 squared plus 8 squared, and then you got a square root. Well, let's move on to something. That looks like a ball, hopefully. We're going to talk about a sphere. We're talking about a sphere with a radius of 6 inches. A sphere only has one, it's three-dimensional, but it only has one measurable dimension. It's its radius or its diameter, depending on how you look at it. Now, I could derive all the other formulas that we've used. I've derived them for you. I've showed you where they come from, that idea of a length times a distance moved. And our volumes, the idea of an area times a distance moved. With a sphere, the only way I could do that would require some relatively advanced calculus. We don't have 12 weeks to get you up to the point where you'd understand that derivation. So this is going to be one of the few times I just give you a formula and ask you to believe me that it's true. The volume of a sphere is 4/3. Now that's a constant, 4/3, times pi times the radius cubed. So the volume of this sphere with a radius of 6 inches is 4/3 times pi times 6 cubed. Now on my calculator, I just type it 4 divided by 3 times pi times 6 to the power of 3. 904.32. That's going to be in cubic inches. So that's our volume. The surface area. Notice I don't label it as total surface area or lateral surface area because the sphere only has one surface. It wraps around the whole thing. Surface area is 4 times pi times radius squared. The 4 is also a constant. So for this one, it would be 4 times pi times 6 squared, otherwise known as 452.16 square inches. What do you think? Pretty neat? Cool.
You only got one yap, so.
What's that?
You only got one yap out of him, so.
Oh, well, the rest of you will come around to it. There was a packet I handed out to you a while back. Actually, you know what? I think I might have to give you a new packet. And this new packet is going to be page 179 through 194. I think I got to give you a new one for that. So I will hand that out right now.